Welcome to the new video lesson on trigonometry. It's 7.1, new chapter, applications of right triangles. Today we'll be solving three basic categories of problems. The first category will be solve right angle triangles, and then we'll solve some word problems using right angle triangle property. And the third category will be solving bearing related problems, bearing of an object. So for the first category, we need to know a few things. First one, Pythagorean Theorem, which you already know, I guess, and some basic properties of a right angle triangle. So let me remind you the Pythagorean Theorem. The hypotenuse squared equals to adjacent square plus opposite squared. You can say the other way also. And we know for a right angle, for any triangle, the sum of all three angles is 180 degree. So for this triangle right here, you can see AC is the hypotenuse, AC is the opposite. If we consider angle B is the acute angle that we are considering for the current situation, then AC will be the opposite and BC or CB will be the adjacent side. Okay, so these are the things that we need to know before starting to solve the first category problem. So here's the first problem. Solve the right triangle around the lengths of sides to one decimal place. So as you can see, we are given the hypotenuse, but we don't have any information about the other two sides. However, we have one angle given 28 degree, and since this is a right angle, we know the angle C is obviously it's 90 degree. We can find angle B. If we consider this is theta, we can find angle B as this 90 degree minus 28 degree. Oops. And we get it is 62 degree. Now if we consider this triangle and this is our angle theta, then we can find sine theta, sine 62 degree, or we can also keep going with the given angle 28 degree. So let's go with the given angle. So sine of 28 degree equals to A. If we consider this is our acute angle, then BC or CB will be the opposite, and the hypotenuse will not change. So it's 14 HC, or we can write A over 14.8, and then using a calculator we can find the value of sine 28 degree is approximately I don't have the calculator, so let me multiply both sides by let me rewrite this line as this. So A equals to 14.8 times sine 28 degree. So from here we can write A approximately, if you use a calculator, you'll get A is approximately 6.9. Now similarly, if we want to find B, then we can use this angle theta. So we can write sine of 62 degree equals to B over 14.8, and then we can simplify this as B equals to 14.8 times 62. Oops, sorry, it should be sine 62 degrees. Then if we use the calculator, we'll get an approximate result of 13.1. We are done. Okay, so let's do the next problem. Solve the right triangle around the measurements to one decimal place. So here you can see AB is given, that's 20, CV or BC is 9. What we don't know about the angle A, angle B, and the side AC. So how can we get information about the side AC? We can use the Pythagorean theorem. We know C squared, hypotenuse squared equals to opposite square plus adjacent square. Since we're not determined which angle to consider this time, but we're certainly know that the side AB is the hypotenuse, and the other two sides either could be adjacent, the other one could be opposite, so it doesn't matter actually. So C squared equals to A squared plus B squared, and we can substitute the values here. 20 squared equals to A squared. We have the values for A, so A is 9 squared plus B squared, then this is 400 equals to 81 plus B squared, and we get, if we subtract 81 from both sides, we get B squared equals to 319, and if we take the square root, we get B is approximately equal to 17.9, taking the square root. So we got the value for B. Now we can find the angle A and angle B. So to find the angle, we need to use the inverse trigonometric formula, inverse function. So cosine B equals to A over 20, and from here we get B equals to cosine inverse 9 over 20, and if we use the calculator, we get an approximate result that is equals to 63.3 degrees. Similarly, if we use the property that the sum of three angles is 180 degrees, we can use that formula right here to find the other angle, or we can use trigonometric formula, trigonometric definitions as well. So let's use the easier one. So angle A will be equal to, I think we should use approximation, 180 degree minus 90 degree, the angle C, minus angle 63.3 degrees, and that gives us equal to 26.7 degree. That's all. Now we are moving to the next category. A surveyor, the problem is it's solve applications of right angles. A surveyor stands on level ground 100 feet from the base of a lighthouse. He measures the angle from the ground to the top of the lighthouse to be 18 degrees. Round to the nearest foot, what is the height of the lighthouse? So let's say this is the height, this is H, and the surveyor is somewhere here, and let's say the angle created here is 18 degree. And the distance, it says he measures the angle from the ground to the top of the lighthouse is 18 degree. This is the 18 degree, and the surveyor stands 100 feet away, so this is 100 feet. So it seems looks like a right triangle, so we can use trigonometric formula, trigonometric functions to find the height of the lighthouse. If we use tangent, we know tan 18 degrees equal to h over 100. So if this is the acute angle, then the tangent is defined as the ratio of opposite over adjacent. So now from here we can simplify this line. H equals to 100 times tan 18 degrees, and which is approximately equal to 32 feet. Let's solve the next problem. The surveyor stands on level ground 90 feet from the base of a lighthouse. He measures the angle from eye level to the top of the lighthouse to be 28 degrees. If the surveyor's eye is 5 feet above the ground, what is the height of the lighthouse round to the nearest foot? Okay, so the surveyor's eye is 5 feet above the ground, so this seems like 5 feet distance. 5 feet. And the surveyor is 90 feet away from the lighthouse. And this dotted horizontal line creates an angle to the top of the lighthouse of 28 degrees. And we have to find the height x, or we can also write h. So what is the height of the lighthouse? So we need to find this distance. We are saying this is x. We already know this is 5 feet. Okay, so we can form a right triangle right here. This is the adjacent, hypotenuse, and opposite. So again, using the formula, tan 28 degrees equals to x over 90. Oh, it's not 90 degrees, it's just 90. So x equals to 90 times tan 28 degrees, which is approximately equals to 48. If we use a calculator and then multiply back with 90. So we're not done here yet. We have to add this 48 to the height of the surveyor, to the height of the eye of the surveyor. So the total height equals to 48 plus 5 equals to 53. And that's the answer. The next problem, to determine the height of a window in the top of a lighthouse, two measurements are taken from the ground 90 feet from the base of the lighthouse. The angle of elevation from the ground to the bottom of the window is 36 degrees, and the angle of elevation from the ground to the top of the window is 42 degrees. Find the height of the window nearest foot. So we have to find this height, the window. So let's say we are considering two heights. The first one is x. It's measured from the bottom of the window to the ground, and another height y, and it's being measured from the top of the window to the ground. And we're given two angles. The first angle is 36 degrees, and the other angle, it is 42 degrees. So we have two right triangles here. We have to find x and y, and then if we subtract x from y, we'll get the height of the window. So smaller triangle, we can use the tangent formula, tan 36 degrees. By the way, the distance from the base to the measuring point is 90 feet. So tan 36 degree equals to x over 90. So from here we get x equals to approximately 60. Oh, let me show you the calculation. 90 times tan 36 degree, which is approximately equals to 65.388. We're not rounding our answer right here because this is intermediate calculation, but when we'll finally report our answer, then we'll round the answer. Now the larger triangle, tan 42 degree equals to y over 90. Again, I'm putting degrees, not the degree. So from here I'm showing the calculation. Y equals to 90 times tan 42 degree, and that gives us approximately y equals to 81.0364 feet. Now to find the height, we just subtract x from y. So the height of the window equals to 81.0364 minus 65.388, and the final answer will be 16 feet approximately. That's all for today. We'll continue in the next video. Thank you.